All right, people, here we go again. I am now in the ER with Hunter, my youngest son. He is being admitted overnight. He's just really, really sick. And I also have strep throat, so when it rains, it pours. He's going to be okay. He just needs treatment, so we're in the right place. But obviously, I'm not in today, and tomorrow is up in the air as well. So at this point, the sub should have handed you a warm-up, and you should have done the first half. If you didn't, pause this video, go back, do the first half. If you did and you feel really confident in it, you can fast forward this video a few minutes, because what I'm going to do is explain how to graph. And if you feel comfortable in that, you don't need to listen to this. But maybe if you weren't in class yesterday or you struggled with what we were doing yesterday, this few minutes might help you, because I'm going to walk through how to graph and shade this. Again, if you know how to do that, fast forward until we get to the part where it's shaded. So first thing I'm going to do here is I'm going to graph this line. And this is in what's called standard form, because x and y are on the same side of the equation. So I'm going to take away the inequality symbol, and I'm going to change it to an equal to symbol. And I'm going to find the x-intercept by plugging 0 in for y. And I'm going to find the y-intercept by plugging 0 in for x. And I'm going to work my way through each of these problems till x is alone and y is alone. So I end up with 3x plus 0, which is just 0, equals 30. And if I divide both sides by 10, I get an x-intercept of 10. And 3 times 0 is 0, and 0 plus 6y is just 6y. And if I divide both sides by 6, I end up with a y-intercept of 5. So over here on my graph, I'm going to make a point on the x-axis at 10 and the y-axis at 5. And we talked yesterday in class about how important it is for you to use a ruler at this point, because the corner points are going to be intersection points, and we want to make sure that they intersect really perfectly. So I'm just doing my best to make sure I'm going right from the middle of one point to the middle of the other. So that's my first line. The next line I'm going to graph is also in what's called standard form. So I am going to take away the inequality symbol and make it an equal to, and I'm going to find the x-intercept by plugging 0 in for y, and I'm going to find the y-intercept by plugging 0 in for x. And when I work through this, I end up with x is 6 and y is 6. So on the x-axis, I'm making a point at 6, and on the y-axis, I'm making a point at 6. And again, I want to take that ruler and I want to go right through the middle of my points. So now I have my second line. And then finally, my third line. And this is just an x equals, and so this is going to be a vertical line. So basically, at x's floor, it's going to go up and down. And I'm just going kind of all the way up. So I'm making sure I have a really straight line. That is not a good example. Let me use the ruler. Use your ruler. And you're going right through the middle of the points. Alright, and what this is going to do is it's going to create a bunch of different regions in my graph. So I've got, and it doesn't matter how you number them, if you number them in the same order as me or not. What's important is that you recognize that with all of these lines, there are 7 different regions. Now what we're going to do is we're going to test our point 0, 0. That's our test point. So for the blue line, if I test 0, 0, I get 3 times 0 plus 6 times 0. 0 is less than or equal to 30. And that's true. So if I'm looking at the blue line, which is this one I'm highlighting here, this point is true. So I want to shade with this point. I want to shade all the stuff with 0, 0, which ends up being 1, 5, 6, and 7. We're not actually going to shade that. We're just going to write those numbers down. 1, 5, 6, 7. Now I'm going to do the same thing down here with the red. 0 plus 0 is greater than or equal to 6. 0 is not greater than or equal to 6. So I'm looking at the red line. But now this point doesn't work. So I don't want to shade with that point because it doesn't work. I want to shade against that point to the area that does work. So I would shade everything up here, which is 3, 4, 5, and 7. I'm not actually going to shade that. I'm going to jot it down. 3, 4, 5, and 7. And then finally, I'm testing the purple line. 0 is less than or equal to 4. And that's true. So, purple line, here 0, 0, it's true. So everything on this side of the line is also true. So I would shade this way, which would give me 1, 2, 3, and 7. And the consistent thing across the board here is 7. All right. And so my shaded region ends up being this triangular shape in the middle. And what we talked about yesterday is everything in pink is a possible solution, but the corner points are the best possible solutions. So while everything in pink works, this, and this are the best possible solutions. And so we're going to list those as coordinate points. So this first point here is 2, 4. This point here is 4, 3. And this point here is 4, 2. That's what we covered in class yesterday. So now, today, what I want to talk to you about is, well, what do we do with that? Like, what's the point of the corner points? Well, eventually, you're going to be given something called an objective function. And when I think of the word objective, I think of like goal, like the goal. And there are two types of goals. There's the profit goal and the expense goal. Think about if you're a company, your profit goal would be to make the most money. But if you're a customer, your expense goal is to spend the least amount of money. So the answer that you choose is going to be dependent on the problem and the question and the situation, okay? But for these examples, we're going to find both the profit, the high number, and the expense, the low number. And then when I am in class again, we'll talk about like in which situations do we use each of those, okay? So for today, you're going to be given this thing called the objective function. So for this example here, I'm giving it to you as 2x plus 6y. That's not always the objective function. It can be a bunch of different things, but that's the one I'm giving you for this problem. So basically what I'm going to do is I'm going to take my corner points, which are coordinates, and I'm just going to plug them in for x and y in this equation. So I get 2 times 2, because x is 2, plus 6 times 4, because y is 4. So I get 4 plus 24, or I get a p of 28. Okay, so if I'm doing the objective function here, I'm going to plug 4 in the x spot and 2 in the y spot. 2 times 4 plus 6 times 2. 8 plus 12. So I get a p of 20. And then if I'm plugging it in for this last function, 2 times 4 plus 6 times 3. 8 plus 18. So I end up with a p of 26. So what does that mean? Think about like the example we did yesterday with like plain pizzas and pepperoni pizzas, right? The shaded region is the constraints that the company has, right? So they only have so much pepperoni to work with. They want to make so much money. They only have so much workers. The pink is what they can do. The corner points are the best possible things they can do. So like 2, 4 would mean like 2 plain, 4 pepperoni. 4, 2 would be like 4 plain, 2 pepperoni. 4, 3 would be like 4 plain, 3 pepperoni, right? So now I know that here's what the profit would be for each of those. So if they did this scenario here, 2 plain, 4 pepperoni, they'd make 28 bucks. maybe that's not this situation, but just to kind of give you an idea of what it could mean. 4 2 plain, we'll say 4 plain, 2 pepperoni, they'd make $20. 4 and 3, they'd make $26. So the minimum amount that they could possibly make with their stipulations is going to be 20, because that's the lowest number of these three numbers. And that's going to happen at 4 and 2, the coordinate point that is associated with that. And the maximum, which is the biggest number, is going to be 28, and that's associated with 2 and 4. So basically this new concept of today is, I'm going to give you this thing called the objective function. I want you to take what we know about corner points. I want you to plug the corner points in and see what the min, smallest number, and max, biggest number is. So now what I want you to do is flip your warm-up over and take all of that into consideration and try the problem on the back.